Well, hello, climate change, brother.
Hey, brother, how's it going? How you been doing?
Pretty good.
You've been doing a lot of stuff for your preparation for your wedding, your daughter's wedding coming up in a couple months. You've been working outside doing a lot of landscaping.
Yeah, that's one of the things I'm doing. I'm trying to, but my friend of mine here locally, he taught me, he goes, hey, don't plant plants that need a lot of water. Plant some nice, beautiful plants. There's hundreds, thousands of desert type plants that don't need a lot of water that are really pretty. That's one way of helping, out a little bit about the CO2 problems and global warming and is that
Planting more trees.
To
take in more carbon dioxide.
Yeah.
Point number 1. Does most of the world believe in climate change? Weather data does show that our surface temperature is rising. Is this caused by man-made carbon emissions?
What do you think about all these measures they're taking about climate change? Do you think it's working, or do you think the world in general is believing that there is such a thing as climate change and that we're doing the right things to solve it, you think?
My opinion, it's always I do think that there is climate change, and I think the Earth is warming. We can measure those statistically with the measurements we've taken over the last 100 years or so. We can tell that the Earth is warming. Let's agree, I think everybody can agree, maybe over 90% of the populace can agree that just by looking at records and statistics that the Earth is warming. Okay, it's about 1.3 degrees Celsius so far over the last 100 years or so, right? So, but most of that's come in the last maybe recent history. So, I think since the 1960s or so.
But when I was taking a course on climate change, they do say that the problem is from the anthropogenic carbon that's coming from under the ground, because that's an extra source, because the Earth usually has a way of balancing out all the different carbon sources and sinks. But that little bit of extra carbon that comes out from underground, that's from petroleum, that's from transportation and electricity, that is supposed to be adding to the problem and making global warming more of a threat.
Well, I definitely agree. It adds to it. Again, unless the whole world stops pumping petroleum or whatever and stops using it, maybe that'll make a difference. But we're one of the largest countries. But again, if the whole world did that, you definitely need to see a significant change. But you would also see a significant collapse in our whole society and economy. So I don't know that that's viable.
Point 2. Is climate change being caused by positive feedback loops that respond to more carbon dioxide and increasing temperatures? What are some positive and negative feedback loops?
Well, we talked a long time ago about feedback loops. Remember that?
Yeah, the feedback.
That might be so what is a feedback loop, and how does that relate to climate change?
Well, it's a cycle that's amplified. It gets an amplification effect where it contributes, say, more carbon dioxide or higher heating. And there's ones that are positive and negative. So it goes opposite to what you would think, because the positive ones actually contribute more towards climate change or global warming, and the negative ones kind of counteract it. They kind of go more towards the cooling effect. So, for example, the one that people use the most as positive and negative feedbacks have to do with the ice in the Arctic.
Yeah, that's a good one.
The melting or the forming of ice, and that most has to do with cloud cover. So if you have cloud cover, you don't have as much solar radiation coming in. It gets reflected by the clouds.
Yeah.
And so when that happens, it cools off more in the Arctic and more ice forms.
Right. So that's a negative feedback.
So that's a negative feedback loop. But the positive one is the opposite. So if you don't have a lot of cloud cover and all this radiation comes in, it tends to melt the ice, and more of that radiation gets absorbed by the oceans, and it heats up the ocean more, and it melts the ice more, and the temperature gets hotter. So that's a positive feedback.
Yeah,
so that's an example.
Spiraling out of control if that keeps going that way, right? So yeah.
There's another example with plants. It's a little bit. So now carbon dioxide and temperature have a lot to do with each other. So if you have a resultant rise in temperature with plant life, the plants tend to dry out more. There's more evapotranspiration, and there's more of a soil degradation, and then you get a problem with more carbon dioxide coming out of the soil in the ground. So that happens with higher temperatures. But at the same time, if you have more carbon dioxide, you get what's called the fertilization effect, where you get more plants growing.
Yeah.
And when you get more plants growing, they take in more carbon dioxide.
Right.
So that's like the negative
loop. Yeah.
That's the negative feedback that counteracts global warming. But at
Right.
the same time, if you have too much temperature, the plants don't do as well, and it becomes like a more towards land degradation.
Point 3. Several different factors cause desertification, which is another result of rising temperature and other weather changes from climate change.
So what about desertification?
Desertification, yeah.
That's sort of a feedback loop. More deserts being formed around the world at a faster rate because of what exactly? What's causing that?
Well, I would think it has to do with several things. It has to do with erosion, soil erosion from flooding, the soil degradation from the plants not growing as well. With that, a less amount of water, droughts. So less water you have, the less amount of plants that can grow.
Right.
So those three factors seem to be the main ones. There are other ones, and that is a legitimate concern for climate change because you have people that live there and you have your agriculture. So what do we do if climate change keeps going on, but if we don't account for more desertification, it's going to affect the populations of the world because a significant amount of people live in deserts. Like you say in the Middle East and even here, like we live in the Sonoran Desert.
Point 4. Positive feedback loops affect sea level rises by heating the oceans more and releasing more carbon dioxide.
What causes the sea level rises? I mean, what feedback loop is that contributing to that? Is it the warming of the ocean currents or ocean temperatures?
Yeah, I've heard several different aspects to it. So, like, the melting of the Arctic ice is supposed to add more fresh water, and for that reason, it's supposed to make more water. But that might not be the main cause of the oceans rising. From new research that's been done by professors like Professor Russell at the University of Arizona, she advocates that the reason that we're having more sea level rises has to do more with the mixing of the ocean with stronger wind currents and ocean currents going down towards the South Pole because there's not a lot of land that gets in the way. And due to the ozone layer that's disappearing because there's more fluorocarbons being emitted every year, it's causing a bigger hole there. And then as the temperature is rising anyways, as it's rising, you get more stronger currents and winds in the ocean, in the Southern Ocean, and those tend to mix more. So the water will sink down more and then it will upwell. So that'll bring in all the air temperature and mix it into the ocean and cause the ocean to get a little warmer. And then at the same time, it takes the carbon from the bottom of the ocean, all the dead matter, and it brings that up and you get more carbon dioxide coming out of the oceans as well.
Right.
So you have like a several-fold problem. And so then so as you heat up the ocean water, it expands. So that's why
it expands.
It makes the water expand more. So then you get a resulting sea level rise.
Right.
Point 5. Release of more methane isn't really affecting climate change as much. Overall, methane levels haven't really risen that much, and man-made methane contribute much less than natural methane sources.
But yet, when you do all this carbon accounting, like say out of the billions of tons of carbon dioxide equivalents that are in the atmosphere, they count methane as a lot, but from what I researched, it really doesn't make that much of a difference from what we're seeing because if you look at the amount of greenhouse gases that have been increased in the atmosphere, methane stayed about the same for the last 30 years. So it has a way of scrubbing it out of the atmosphere.
Right.
And so all this big deal we're making about methane, I don't think is really warranted. I think because they count it as 20 times like equivalent of carbon dioxide. So for every ton of carbon dioxide, you're counting 20 or more tons of methane.
Right.
When I think all these measures we're taking as far as like a methane tax that they're doing from this Inflation Reduction Act is not really warranted, I don't think, because you're charging like 10 to 15 times more per ton for methane release. And it is nothing compared to the natural sources of methane that's coming about. And those we have to worry a little bit from global warming because you have the methyl hydrates from the oceans that can come up that can cause more methane release. You have the permafrost that's melting that can cause more methane. And you have like marshes that are degrading that cause more methane. So from all those sources, I think you get a lot more methane than you would from, say, if all the cows that release methane from eating and all that, by the gas stoves and by the oil and gas industry from the leaks and the pipes and all that. I don't think it's as much even in comparison to the natural sources of methane. So I really don't think they're concentrating on the wrong thing as far as what
it's not
when
a
it comes
good
to
example.
carbon accounting,
Yeah, and that's a good example. I mean, my understanding is too that we had this in another video we did, but the methane gets scrubbed out at about every 10 to 20 years. And so, but CO2, how long does it take to get scrubbed out of the atmosphere?
Yeah, they say it takes several hundred years for it
it's a
to
long
break
time.
down. Yeah.
So that's a big concern. much more of a concern than methane. I think you're right. Very good. Well, okay. Well, until next time, we'll give you some updates about some of the stuff we're doing, maybe some of your experiments too. So we'll try and get going on those. And so, but until next time, we'll wish everybody some good luck and good measures in mitigating climate change.
Exactly. Good point there.